Hey, we're going to do some transformations. Whoop, whoop, whoop. Okay. We are going to identify and perform transformations of linear functions. So we are going to start out with our good old friend, the linear parent function that we met in Unit 3. So remember that if we take our usual suspects, -2, -1, 0, 1, and 2, and we plug them into our linear parent, it's really rude and just spits the same stuff right back out at us. The output is the same as the input. So if we wanted to graph that, it would look like this. Put in a 0, get out a 0. Put in a 1, get a 1. Put in a 2, get a 2, and so on, all the way across our grid. Okay. Okay. So, whoa. Okay, I think we're back. Okay. Now we are going to talk about some transformations. Now you can probably see in the word transformations the word transform, which means change. So these are going to be changes to the linear parent. So there's only a couple things we can change about the linear parent. Okay, it's going like this, right? I don't know. I think it might be backwards to you guys. I don't know. Well, whatever it is, we can only change like its slope, right? Okay, or we can change where it is hitting the y-axis. So that's its y-intercept. So those are the only things we can manipulate. So the first thing that we can do is make the slope negative, okay? And that would be with a reflection over the x-axis. Okay, if we multiply our x by a negative factor, that would make the function slope negative. So instead of going up like the parent goes, if we make it negative, I'm going to do the parent in pink like I had it. Okay. Parent, normal, regular parent, positive slope. If I multiply it by a negative, okay, now it's going down. It's got negative slope. All right, the next thing we can do is a vertical stretch. Okay, if we multiply x by a factor greater than 1, okay, that will make the function slope steeper. Okay, so here's parent again. And if I make it steeper, it's going to go like, woo, like that, like steeper. Okay, so that would be numbers like 2 or 3 or 4 if you multiply by those. Okay, the next thing I can do is instead of stretching my function vertically, I can compress it. Okay, so that would be multiplying x by a factor less than 1. Oops, that was a lot of line for just the word less. Okay, less than 1 will make it less steep. We've already seen this. If you have a slope like 1/2 or 1/3, you're going to get kind of a flat looking slope compared to the parent. All right, last thing we can do is a translation or a shift. Okay, adding or subtracting a constant will shift the function's y-intercept up or down. So when we have a y equals mx plus b, the b is in charge of the shift. Okay, that is what's going to change our y-intercept. Okay, so let's look at these. All right, so remember that our parent, I'll do the parent in pink for each of these. We'll just kind of sketch the parent on here. Oh, that was terrible. I can do better. Okay, that's my parent, 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 and my parent. Okay. Whew. So when I look at this, I see that I have a negative in front of my x. Now if I put that in my calculator, I put in negative x and graph it, you can see that now I get a line with a negative slope, just like we promised. So what's happening is that my slope is -1. So my m is -1, and you can see that I have a 0 for my b value. So it still has a y-intercept of 0, 0, but now it's going down 1, right 1, down 1, right 1, down 1, right 1. Okay, so I have to identify the transformation. So that is a reflection in the x-axis. Okay, if you can imagine, like the x-axis here is like a mirror, or like the surface of a lake. Okay, this point right here got reflected right down there. This point, oops, that's the reflection. This point down here got reflected up there. Okay, so hopefully you can see what happened there. Okay, next we have y equals 3x. Well, my b value is still 0, so I'm going to start at 0, 0, and my slope is 3 over 1. So I'm going to rise 3, run 1, put a new point. Rise 3, run 1. And then I can go backwards too. I can go down 3 and back 1. Okay, that gives me these points. Okay, that function is way steeper than my parent. Okay, it got stretched vertically. It's the y's that got stretched. The y's got multiplied by 3. Okay, so this does not have a rocks. So, whoops, I meant to say no rocks. No rocks. That's reflection over x. But we do have a vertical stretch. Vertical stretch. And of course, it's math class. We have to be specific. We can't just say it's stretched. We have to say by how much. So we have to say by a factor of, what did we multiply by? 3. By a factor of 3. Okay, next. Now this time we're multiplying the x value again, but we're not stretching it. All of my y values are going to be as fourth as high. Okay, they're going to be a lot lower, or they're going to be squished. Not all of them are lower. Okay, that was bad. I shouldn't have said that. I got distracted because my parent function was wrong. Okay, so I'm going to start at my y-intercept 0, 0, and I'm going to rise 1, run 4. Okay, and then to get another point, I can fall 1 and crawl back 4. So this is my new function, and you can see that it is less steep. If it is less steep, it has been vertically compressed. So again, I don't have a rocks because my slope is still positive. I have no rocks. But I have a vertical compression. Now I have to say how much. Okay, by a factor of 1/4. Okay. Squished. All right. Letter D. So this time my B value has been shifted down 2 units. My B is at 0, -2. That's my y-intercept right there. Okay, my slope is still 1. So I get to rise 1, run 1, rise 1, run 1, all the way across. Notice that this particular transformation is parallel to the parent because I did not change its slope. I just shifted it down 2 units. So we didn't do a rocks. No rocks. Okay, we have no vertical stretch or vertical compression, but we shifted. So we translated or shifted down 2 units. Oops. I didn't mean to put my, okay, I messed that up. Your teacher probably could have done this better. There, shifted, translated. Okay, so that's the kinds of transformations that we're going to see. Now, the exciting thing is that we can have more than one at a time. So we'll see that, I guess, on the back. Yes, on the back. All right, so let's graph this function. We have g of x equals -1/2 x plus 3. So my m is -1/2, and my b value is 3. My y-intercept is 0, 3. So 0, 3, that's up here. And then I'm going to use my slope to find additional points. So I'm going to rise -1 or fall 1 and crawl 2. Fall 1, crawl 2. Fall 1, crawl 2. Okay, make sure that if you have a negative slope, that as you read your graph is decreasing from left to right like you're reading a book. Okay, so we've got a lot going on here. First of all, we have a negative slope. So that means that we have a reflection in the x-axis. Reflected over x-axis. Okay, next, we multiplied by a factor other than 1. We multiplied by 1/2. So that vertically compressed our function. Vertically compressed. And then I have to say how much? By a factor of 1/2. Notice that both of these came from my slope. From slope. Okay, my last transformation, I'll do this one in another color, comes from my b value. Notice that my y-intercept shifted from the origin boop, 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 up 3 units. Okay, so that's my last one. Translated or shifted. You can say whichever one you want, shifted up 3 units. Okay, that's it. And that one we had 3. Holy Hannah. All right, let's try another one. This one we have h of x equals 4x minus 1. So my m is 4 over 1. That's my rise over my run. And my y-intercept is 0, -1. So I start at my y-intercept, 0, -1, and I rise 4, run 1. Rise 4, run 1. I'm off the grid, but that's okay. I can go backwards too. So I can fall 4, crawl backwards 1, and get another point. Okay, connect them. Make sure you've got arrows on both ends. Okay, now we've got a couple of transformations here. We do not have a reflection over the x-axis because our slope is positive. Okay, so we've got no rocks. Okay, we do have a vertical stretch. Look how much it got stretched vertically. Okay, I could do that for a while. Okay, so it got vertically stretched. Okay, by how much? By a factor of 4. All right, so far both of these come from the slope. Okay, the very last one comes from my y-intercept, which is 0, -1. Boop, boop, boop. Boop, boop. So this has been shifted down 1 unit. Okay, this one came from the y-intercept. So now that we've done a few of them and you've gotten to see what they look like, we're going to predict what these transformations for the next 3 would be. All right, so the slope for g of x is positive, so I know that I will have no rocks. Okay, it does have a factor other than 1 in front of the x, so I can tell that there is a stretch or compression. Now 2/3 is not as big as 1. 2/3 is smaller than 1, so that's a vertical compression. Squished, not stretched. Okay, so I have a vertical compression by a factor of 2/3. And then last, you can see that I have a -1 for my b value. That gives me a shift down 1 unit. Now, we can check that on the calculator. So here's my parent, y equals x. Okay, that's the parent in blue. Now I'm going to add our transformation. 2 divided by 3 times x minus 1 graph. So you can see that my y-intercept shifted down a unit. And then you can see that the red transformation function is not as steep as the blue parent one because it got vertically compressed. Okay. Just in case you thought I was making it up. All right, the first thing I see is that we have a negative slope. So a negative slope tells me that I have a reflection over the x-axis. Okay, the next thing I see is that it's just a -1. So I'm not multiplying by 2 or like by 1/2 or 2/3 or anything. So I don't have a stretch or compression. I only have that reflection in the multiplying. So I have no vertical stretch or vertical compression. Okay, the last thing I see is this +5. That means that I have a shift up 5, that looks like an S, 5 units. Okay, let's check it on the calculator to make sure I'm right. So I want my y equals, my first one to still be x because I want my parent so I can see them compared. And what was it? Negative x, was it plus or minus 5? Plus 5, plus 5. Negative x plus 5. Graph them. So you can see that my y-intercept shifted up 5 units. Okay, and its slope is negative compared to my parent whose slope is positive. Cool. Okie dokie, last one for this part, at least. So I have a negative slope again. So that means another reflection over the x-axis. Now, this time I have a negative 3. So before I just had a negative 1, this time I've got a 3, a negative 3. So this time it does have a vertical stretch. Vertical stretch by a factor of 3. And last but not least, my minus 5 is going to shift me down 5 units. When I had plus 5, I went up 5, but this one's going to go down 5. I'm going to say translated this time so we get used to seeing both. Translated down 5 units. It's not just to say, it's not enough to say it went down 5 units. You have to use the words translated or shift. Okay, these are very specific instructions. It's like a recipe. You got to follow it exactly. All right, so the next two, we just have to look at the pictures, which will be nice, I guess. Okay, so just for comparison, let me put the parent on here for both of them. So compared to my parent, you can see that I have a negative slope. So I know that this one has a reflection in the x-axis. Reflected over x-axis. Okay, next I can see that it is less steep than my parent. So I'm going to check my slope. I need 2 pretty points. It's going to go down 1, right 2. Okay, so I know that my m is negative 1/2. Okay, I already took care of the negative when I said that it was reflected, but I have to tell what that 1/2 does. The 1/2 tells me how much my function got vertically compressed. Okay, so I have to say vertically compressed by a factor of 1/2. Okay, and last but not least, you can see that my y-intercept was the point 0.02. So my y-intercept got shifted up 2 units. Shifted up 2 units. Whew. Next one. Last one. Final countdown. Okay, so compared to my parent function, I can see that this function also has a positive slope. So I do not have a reflection over the x-axis. I have no rocks. But look at that slope. Woo, that's steep. That is a steep slope. So let's figure out what the slope is, and then we can see what our vertical stretch could be. So I need 2 pretty points. It's rising 3 and running 1. So I can see my M is 3. That tells me I have a vertical stretch by a, by a factor of, whoa, of 3. Okay, last but not least, you can see that my y-intercept is the point 0, -2. That tells me that I have a shift down 2 units. That's it. We're done. Thank you.